Hello friends, I'm Mohnish and you're watching Codex-Mohnish. So today we are going to look at the vehicle controls in the Carla sensors. Not sensors, but in the cars. So first we are going to turn the vehicle, like first we are going to apply a brakes, then we are going to turn the vehicle towards the left, and then we are finally going to take a U-turn. So let's see how all this happens in the back end, and let's start with the Visual Studio Code here. So I'll just make the font little big. Okay, so and I made this code in three parts. So here one is Act 1 brakes, and one is Act 2 steering, and one is Act 3 U-turn. I just add like this thing so it will be helpful. And then this is all the same story, like we are importing libraries, calling the EGG4 file, and image with image as we are using uh, the sensor, like camera sensor here. And here we are getting the data. We are trying to reshape it and we are trying to show our live preview here. So we discussed it in the last video, and if you have not seen that, like it was of depth sensors and camera sensors, so you must see that. This has a detailed explanation of that code. And so this is the blueprint, like image size, FOV and all that of the, like we are setting up the camera in this function mainly. And then this is the main loop, you can say, like we are calling the client, we're trying to connect to Carla, we are spawning our vehicle, then we are adding the simulation camera, we are setting the location and rotation, then we are spawning the camera. Yeah, here we are spawning it, like sensor equals to world dot spawn actor. We are appending into the list, then we are listening. So here we are having lambda function camera data. So like lambda functions are like when you want to use them period, like you have a huge code but you have want to use a function twice, like it's not a much important, so you can just write a lambda function. So lambda function, so we use the keyword lambda, like this is the syntax, then we use the positional argument here. So here the camera data is the argument which we are getting from sensor.listen, and then this colon is to separate like the parameters from what we are actually going to do. So like this is the instruction, like after the like colon is the instruction, which is image, like the function which we have written here, and then image, and we are sending camera data. So like we use the keyword lambda. So this is a function mainly. Then we are sending the parameter. Then we are keeping a colon to separate the parameter from the actual instruction, and then we are giving the instruction. But in the lambda function, the instruction should be of one line only. So that's the lambda function, and you see we are creator for quite few lambda functions here, like speed equal to lambda speed, Carla the vehicle control, throttle equal to speed. So here we are taking a positional. We can call the speed as a function. So we are using it here. So you see speed as a function. Then we are passing the parameter 0.4, like which is the speed, and then we are setting the throttle. So throttle is the velocity of the car. So we are setting it to the value of the speed. Then we are adding the brake. So here, like similarly brake, we are adding like we are making a function. Then we are giving it a positional argument. Uh, brake, and here we are adding the vehicle control. Handbrake is the parameter here which is recognized by Carla, and brake is our parameter which we are getting through this function, so we must not get confused. And handbrake takes the values in boolean data type, boolean, like true or false. If the handbrakes are true, then it will stop the vehicle. If it's false, then it will keep the vehicle running. And steer, so lambda dot steer magnitude, so steering is like rotating the vehicle. So if I want to rotate right, I would give a positive value from zero point 0.0 to 0.1, like 1.0. And if I want to steer left, so these values are going to be negative. So here we are steering left in all the like scenarios in these three acts. So we are using minus. So first, before we try to understand what's happening, we'll just run the code. Wait, so okay, I'll just okay, I don't need that. So I'll just run my Carla. Okay, so instead, like sometimes we may go through errors, so I'll just run the CMD. I'll just run it from there. CD Windows No Editor. So Windows Node Editor is the place where I stored my Carla. So Carla, and we are going to like run in quality and level low, like because like it's easier to handle out the processes. Then Okay, then I'll just okay. So Carla is activated. So that's what I like. Our Visual Studio, it will just do half of the task for me. So now Python project 206.py. So let's see. Let me set up this view. So now I think it's better for viewing. Okay, so I can't zoom into this terminal, so we have to adjust. So firstly, so you see the car is here and it stopped. So you see the camera view is also showing us that the thing stopped. So why did it stop? So let's see what happens. So drop vehicle, we are applying the control and speed equals to 4. So what's happening? So the whole thing is getting here. So the throttle equals to speed. So Carla dot vehicle control and in that brackets throttle equal to 0.4. So that's what, but what we are seeing is like speed equals to, like speed, and we are giving an argument 0.4 as a function. But what's actually happening behind, like here in the behind, like in the C++ signature, like you'll see if you do any errors here, like you'll get C++ signature thing and all that. So I call like in that, so you can see the Carla dot vehicle control throttle equal to 0.4. So that's how it's going to interpret the whole thing. So like if you are not able to understand, so you can rewind and see it again. And the similar thing for brakes. So here we are giving a positional argument, the brake. So don't get confused with this name and this name. Like brake is the function, and here break is the argument here. So I'll just change it to break underscore one, and here break underscore one for your convenience. Okay, so okay, this is one. And now if you run the code, then also we'll get the same output. I'll just control C it and I'll just run it again. So we should get the same output, and we know we will. So it's the cast out. So this is argument, and this is the function. So we should not get confused between it. And so we are giving an argument which is true. So here vehicle dot like we are applying the control here, and Carla dot vehicle control handbrake equals to true. So brake one has the value of true, so it's setting into true. So the handbrakes are getting applied. And time dot sleep is like for seeing the actions what's happening. So we are done with the activity one, which is the brakes. Now we'll just go with steering it towards the left. Like so what we are going to do here actually. So we see this car. So we'll just deviate this from its main lane, and then we'll take it to this lane by trespassing. So we'll just pass this footpath or something like divider. So here, as there's no traffic police, so we are free to do that. No challan, nothing. And now now we see the car turn. Like I just uncommented few lines. You should have seen that. If you didn't, so now the car goes zooey, and you see it's like applying in the camera view also. So I don't need to go behind the car always to see what's happening. So that's why I just kept this camera view. I'm just seeing that. Okay, I'll just okay. So what happened here? So we are using the speed function. So I just explained it. It's a function, lambda function. We are giving a positional argument 0.4. So if I just hover on this speed, so it's a variable speed. We're just taking a positional argument speed. So you can see, and it can be any value. Like we, I'm not specified like should be integer and all that. So and now we are trying to give it steer. So steer again is this one. So steer we are giving it to like some steer magnitude like minus 0.7. Minus is for left turn, and then again we are trying to go straight. So that's what we did here. So I'll just run the code again. So you you can understand what was happening here. So first again I'll just go through that. So you see I automatically came as my correspond because I gave the forward vector thing here. So here you see I have kept a forward vector something here. Where's that? Okay, like couldn't find a forward vector. So I just showed a little while. Okay, so I think the car just went away. So you can see the camera view, of course. Like you don't need to run behind the car. Okay, so wait, where's the car? Did it hit somewhere? Okay, so it reached there already. So a car just bashed into few barriers. So like, see, so you see how it took the left turn, like it's very smooth, and we just passed that thing. without anyone interfering. And now we are going to look through a code for U-turn. So U-turn is like we are going to just, I'll just spawn the car. Okay, sorry. I'll just spawn the car and you see what happens here. I'll explain the code after the execution here. So if the car will go from this lane to this lane and you see how it happens. So it will just turn a little more. Like so, like my U-turn was not so smooth. Like I'm not a good driver yet. So I just crashed into a wall. But you don't crash. You can see the arguments properly and you can just set the value. So I just, for the video sake, I just made it fast. So first, I just applied a speed. So first you saw it started moving. Then applied a brake. Then again it like took some speed. Again, then again it was trying to move left. You saw it try to move left. So I increase it to like some 9 seconds. You see what will happen. Then I try to again apply speed and I try to sleep. So you see that's what the code happens. So first I applied a speed, then I applied a brake, then I applied some speed again. Then I applied a speed and brake, so it will turn. Then I applied again a speed, so it will move forward. So we can see like it had actually taken a U-turn or not. So I just run this code once again. So we may now understand changes with the code. What happened here? So you see first it was moving, then turn left, turn left, turn left, turn left properly. So I think this will bash in a tree mostly. I think no, it didn't. So you see, this turn was kind of like not so good, but then also this is simulation, so there's no threat that the car will get destroyed. So it's completely okay. So we see like we are able to do a U-turn here. So if we just precisely write the code, then we may be able to see the perfect U-turn. So that's it for for today, friends. Thank you for watching the video, and if you're watching it till here, then please like and subscribe the channel. It motivates me to make more such informative videos. Thank you, friends.